Welcome to Formula 1 Maths. This is Mixed Exercise 9.01, GCE A-Level Pure Maths, Year 1. Mixed Exercise 9.01 is on trigonometric ratios. We've got two questions to answer. Question 1. The diagram shows a triangle, ABC. AB is 5 centimeters, AC is equal to 6 centimeters, and BC is equal to 4 centimeters. A. Show that cos theta is equal to 3 over 4. B. Hence or otherwise, find the exact values of sine theta and tan theta. For A, we are given a triangle with 3 given sides, 5 centimeters, 6 centimeters, and 4 centimeters. We also have an angle, theta, the cosine of which we have to find. So with this information, we will need to resort to the cosine rule, which states that a squared is equal to b squared plus c squared minus 2 times b times c cos A, where A is the side opposite angle A. If I have a triangle like this, and I label the vertices A, B, and C, this side facing the angle A is lowercase a, and this side facing angle B is lowercase b, and the final side, which is facing angle C, is lowercase c. So with this information here in this triangle, I'm going to substitute theta for uppercase A, and that means I will have to substitute 4 for lowercase a over here. Then I can substitute 5 for B and 6 for C. And so if I do that, I'm going to get 4 squared is equal to 5 squared plus 6 squared minus 2 times 5 times 6 cos theta. If I simplify, I'm going to get 16 is equal to 25 plus 36 minus 60 cos theta. Now, to find cos theta, I'll need to rearrange and take this to the other side of the equation to make it positive, and bring 16 over here to the side. And then I'm going to get 60 cos theta is equal to 25 plus 36 minus 16. Simplify to get 60 cos theta is equal to 45, and then solving for cos theta will give you 45 over 60. Simplify the fraction, and you get cos theta is equal to 3 over 4, as required over here. And for B, before we go and find the exact values of sine theta and tan theta, I need to show you how not to solve this question. So, having got this value here for cos theta, you might go ahead and do this. Cos theta is equal to 3 over 4. That implies theta is equal to cos inverse of 3 over 4. And you're going to get 41.4 degrees. And then you're going to go ahead and say sine theta is equal to sine 41.4, and that will give 0.661. And then you go ahead and do the same thing for tan theta. But that is not the right way to answer this question. So you should not do this in an exam. No matter what you do with a calculator, you're not going to get exact values here as required over here. So this word exact is very, very important. So how do you do this then? There are two ways to solve this question. The first one is to draw a right angle triangle like this. And then, because we have got cos theta is equal to 3 over 4, and using the definition of cosine theta, which is cos theta is equal to adjacent over hypotenuse, I can decide to put theta over here. If I put theta over here, then this becomes the adjacent side, and that becomes a hypotenuse. That means, because this is theta, I can put 3 over here, the adjacent side, and then 4 over there, which is a hypotenuse, in accordance with the definition for cosine. And at this point, let me point out that you should not confuse this triangle, which is a right-angled triangle, with this triangle, which is a scaling triangle. With this triangle, the side opposite the angle is 4, but it's not the case here. So this triangle is completely different from this triangle. So you should not confuse the two. Now that we've got this triangle here with 3 here and 4 here, if we are able to find this length here, we can easily write down sine theta and tan theta. So to find that, let me represent that by x, and then I'll go ahead and use Pythagoras Theorem to find x. And according to Pythagoras Theorem, x will be equal to square root of 4 squared minus 3 squared. So x will be equal to root 7. So let's replace the x with root 7. So I've got all the sides of this right-angled triangle here. I can easily now write down the values of sine theta and tan theta. Sine theta is defined as theta is equals to opposite over hypotenuse, and tan theta as opposite over adjacent. And so sine theta will be equal to root 7 over 4. And then tan theta will be root 7 over 3. And that's how to find the exact values of sine theta and tan theta. The second method is using this identity. Sine squared theta plus cos squared theta is equal to 1. We know the value of cos theta. So we can substitute 3 over 4 over here to get sine squared theta plus 3 over 4 all squared equals to 1. And if I do that, I'm going to get the following. But 3 over 4 all squared is 9 over 16. So if I rearrange, I'm going to get sine squared theta is equals to 1 minus 9 over 16, which will give 7 over 16. But I need to find the value of sine theta, and that means finding the square root of 7 over 16, and that will give root 7 over 4. And it's the same answer that we got over here. We can use yet another identity, sine theta over cos theta equals to tan theta to get the value of tan theta. So if I do that, I'm going to do the substitution, and that means sine theta, which is root 7 over 4 divided by 3 over 4, which is the value for cos theta. And then this means we are going to multiply this by the inverse of that, which is 4 over 3. I can now cross out 4 and 4. That will be 1 and 1. And then that will eventually give root 7 over 3. The same answer we got here. So these are the two ways to find the exact values of sine theta and tan theta. Question 2. The diagram shows the journey of a student on a school campus. He walks 600 meters due north from the auditorium at point A to the library at point L. He then walks on a bearing of theta to the canteen at point C. He finally walks back to the auditorium, which is a distance of 900 meters. A. Calculate the distance between the library and the canteen. B. Find the bearing of the canteen from the library. C. Work out the area enclosed by his walk. So the journey of the student forms a triangle, ALC. For A, we are supposed to find the length from L to C. And we have the side AL, which is 600 meters, and the side AC, which is 900 meters. We also have an angle between the two sides, 15 degrees. So with this information, we can use the cosine rule. It says that a squared is equal to b squared plus c squared minus 2 times b times c cos a, where a is the side opposite angle A, and B and C are the other two sides. I'll need to label the distance from the library to the canteen as x. Then, because I've got this angle here and these two lengths, I can substitute x over here and 15 for A. We can substitute 600 for B and 900 for C. And if I do that, I'm going to get x squared is equal to 600 squared plus 900 squared minus 2 times 600 times 900 cos 15. All I have to do now is find the square root of all that. And if I do that and put that in my calculator, I'm going to get 356 meters. So the value of x is 356 meters. For B, find the bearing of the canteen from the library. So the bearing of the canteen from the library means that when you are stood at the library, the angle you turn through to see the canteen, and that will be this angle theta here. But with the given information, we cannot find theta directly. So what we need to do is to find this angle and take it away from 180 to get this angle, because the two angles will be on a straight line. So let's label this angle alpha. Then I can use yet another rule, this time the sine rule, which states that sine A over side A is equal to sine B over side B. If I do my appropriate substitution, I'm going to get sine alpha over 900, because 900 faces angle alpha. That will be equals to sine 15 over the side opposite, 356. I'll then rearrange to get sine alpha is equals to 900 sine 15 over 356. And then find alpha by doing sine inverse of all that. Put that in the calculator, and I'm going to get 40.9. But it looks like we have a problem here, because you can clearly see by the dimensions of this triangle. This is 600, this is 356, and this is 900. This angle is clearly obtuse, but the angle we've got is acute. And this is because sine of an acute angle x is also equal to sine of the obtuse angle 180 minus x. And that means this angle is 180 minus 40.9, and that gives 139.1. But we are looking for theta, and like I mentioned earlier, all we do is take this angle from 180 to get angle theta, and that will be 40.9. But you don't write bearings with decimal points in them, and also you write bearings as 3 digits. And so the bearing we are looking for is 041 degrees. And that's the answer for B. For C, we're going to use another formula to find the area of this triangle. And that formula we're going to use is half A times B times sine C, where angle C is the angle between A and B. So we've got these two sides, 600 meters and 900 meters, and the inclusive angle between them is 15. So we can easily substitute in this formula as follows. Half times 600 times 900 sine 15. And if I put this in my calculator, I'm going to get 69,881 meters squared. And that is the end of this session on trigonometric ratio. Thank you for watching. I'll see you in the next video.